you're running, nah, they shit. I told you that way faster. And y'all ran. Oh, you didn't run.
No, we walked and then we saw. Two making plays.
You not Cindy was late. I was late.
This is fifth period or fourth period? Fourth.
All right, guys, real quick while I'm doing attendance, I've got some questions up on the board. Y'all go ahead and take a look at these questions. You can either get out a piece of paper, write down some notes, or you can just take some mental notes and we'll have a discussion in just a minute on these three questions. They are going to be leading us into our next unit, what we're going to be talking about. This unit, we're going to be working up to our first big project, right? There's a little bit of something we've got to learn about before we just jump into the project. All right, so that's what we're going to start on today. So again, go ahead and take a look at these questions. Again, if you want to do mental notes, or if you want to get out a piece of paper and jot some stuff down, we will have a brief discussion on this, and I will be calling on random people. So if you feel more comfortable having your thoughts out on paper, then I suggest you do that. We'll go ahead and set a little timer. Okay, so like carrying out or following the finishing run, right? So starting from the beginning and going all the way to the end. So carrying out. Yeah, exactly. Right? So carrying out that process is following the steps. Right, so think of it in terms of like language arts. When you do a paper, you can just write the final draft and turn that in. Now we do some kind of brainstorming paper, we do rough drafts, we do revisions, and then we turn it. So process like that.
Let's do the left. I did intro to regular.
Vic told you that LeBron had 8 assists.
Luka Damon had 24.
He played restricted minutes.
Why would you even think he was getting up 20 points? That's like, dude, how you
He hasn't played
manage
like
exactly?
He ain't played like 2 months. Doesn't matter. And he played shit because he's still kind of hurt.
Exactly.
All right, fellas, what should our conversation be right now?
Oh, the parlays.
Huh?
Parlay.
No.
I thought you said the conversation.
Yeah, but what should our conversation be about?
Oh, the issues.
The questions that are up on the board, right? Take some mental notes, or you want to write something down?
We must got people that speak Spanish.
I do. The one that doesn't understand a lot is actually not here today, but my first period, I've got a couple that don't speak hardly English.
That's crazy.
Can't
You
read
know,
it.
all our four kids, we always have somebody in there that don't speak English. I just want to listen to those.
That's what inclusion's all about, right? And make sure, yeah, I think she was in this last class. Carrie Ann. She might have been in the first period. What's up, Chase? In general, right? It can be in general, but a lot of working through a process can relate to not just this class, but other classes. Right? So really, I'm just asking in general. Take just another minute and a half to get some thoughts either in your head or down on paper.
Huh?
What's up, President? Want a piece of paper? Only have graph paper, is that all right? Yep. You got it there?
Big split.
Got it there. You need a piece of paper? I'm just gonna keep it in your head.
Come on, let's do it right now.
You got water on it.
I did intro to Ray Games and intro to Tuesday.
Oh my God. No, what's that?
You have this? We'll get you
Well,
that.
you know she got me up in comp science.
Computer science? That's what you,
Give me an AP comp.
that's what you got right now, right? Computer science, computer
Give
science?
me an AP comp.
You not ready for that?
I mean, AP, computer science.
So she didn't, she put you in an AP
No,
class,
no,
but
no,
didn't
I mean,
expect
not
it?
computer science, but AP science.
Oh, shit.
Whatever it is for my biology.
Oh, okay, yeah.
Lewis.
I got honors.
You like science, man?
I got honors.
No?
I just passed that class so much, you just think I'm so smart, and I'm not. But it's just easy.
I got honors.
Because all
Alright,
you're
guys,
doing is
couple
learning
more
about
seconds.
biology is hard.
Come together.
Should've known.
Alright, when we start to have this conversation, I need the other conversations to a minimum, right? Unless you're discussing what we're talking about, so fellas, give me some, few minutes of your time. Okay, so, now, so you've got lots of great notes now, so, why do you think it's important to work through a process when we're doing different projects? I'm sorry to interrupt you. Guys, hey, y'all need to give this gentleman the same respect y'all want if you were talking, okay? Okay? You can have your conversations on that. Say that again, I'm sorry, Nelson. Okay. Is it okay to make mistakes? Yeah. Yeah? Alright, so that's a lot of time, that's why we work through a process, right? So like I made the example a minute ago about language arts, right? With language arts, I don't just write my final essay and turn that in. I do some kind of brainstorming, I come up with a rough draft, I revise it, make sure it's exactly how I want it and turn it in, right? So this process can be used in all facets of life, right? But when we start talking about what's called the engineering design process, which is what we're gonna start learning about today, it's very similar, right? You're gonna work through a process, you're gonna figure out what it is you're trying to do. Is it a need, is it a want? Am I improving something, right? You're gonna start defining parts of that problem, do research, other things on it until you get to your best solution. Right? Let me get thoughts from one of these fellows over here. Henry, why do you think we come up with multiple solutions to a problem? You don't know why it'd be a good idea? So if you have a problem you gotta solve, would you just come up with one solution? Or something else, right? Just in case, what happens if your first solution doesn't work? You got the other ones to fall back on, right? So when I'm doing, solving a problem, if I come up with just one solution and it doesn't work, now I'm kinda stuck, right? You cooked, as y'all like to say. Did I use that properly? Maybe I should say. Right? So, alright, Derek, since you agree with me, I appreciate that, right? How do I come up with the best solution? How would I do, let me rephrase that based on what it says up. How would I determine that it is the best solution? How it works, right? What the outcome is. Alright, so if I test my solution and the outcome's not great, probably not my best solution, right? So I'm gonna test the next one and so on and so forth until I get the best results that I can possibly get. Right? So again, what we're starting to look at is what's called the engineering design process. I've got a worksheet that I can either give you a paper copy of, or if you prefer typing, it is on Google Classroom as well. Alright, so I'll give you that option. If you want it on a paper copy, go ahead and raise your hand. If you wanna just, again, if you wanna just use a computer to type out, what this worksheet is basically a study guide, right? It lays out the different parts of the engineering design process. You got a paper copy, you can use your computer. Paper, You're welcome. Paper over here. So, you want a paper copy or you use your computer? Computer? Paper copy? Paper copy as well? Chase, Derek, Jonathan, you guys want a paper copy or you use your computer? Fitting in a paper copy or you want to type on the computer? Computer, paper or computer? Computer? Sean, you gonna keep up with me today? We're starting to learn about the engineering design process and how it's gonna build it into our first project we're gonna do. paper copy of the worksheet, or you wanna do it on the computer? On the computer?
While he having questions over there.
You want paper copy on YouTube? You guys want paper copy, or you want, it's on Google Classroom if you're looking for the worksheet?
I got intro Rick games already up there.
You guys want paper copy, or you wanna do it on the computer? Copy, go. On the computer? Right, what you think? Paper copy, and then do it on the computer? Huh? Worksheet? You want a paper copy, you wanna do it, your notes on the paper copy, or you wanna type one on the computer? Paper copy? Alright. Is that everybody want a paper copy? Okay. So, first thing I'm gonna do is I'm gonna show a little video that kind of gives a good example of the design process, right? It's a little silly, right? But I kind of like the way it presents it to you. So, Steve, would you mind grabbing the lights for us? Guys, while this video is playing, I'd prefer the conversations be stopped so that those that aren't paying attention can hear what's being said. So, what you're gonna see on the video is a lot of what's laid out in front of you. Right, so you can go ahead and start taking notes as the video is playing. We will talk about the worksheet afterwards as well. Right, but again, this is gonna lay out the design process in kind of a unique way. So again, while this is playing, let's keep the conversations to a minimum so that others that are trying to watch can watch. Again, I know it sounds a little elementary.
The engineering
but I
design
like the way it lays
process
it out.
is a lot like making tacos. Here's how. Let's say you've had a long day. Maybe you've gone to class. Maybe you just got off work. Maybe you just finished an intense workout session. It's now 7 o'clock and you're hungry. But you've got friends coming over in half an hour. So, what do? You go through the engineering design process. First, you define a problem or need. In this case, the problem is you're hungry and you've got people coming over in half an hour. And they might be hungry too.
Alright, real quick, those that are doing it on the computer, it's on Google Classroom and it's called EDP Worksheet. Oh, sorry. Yeah, after 10 minutes, or after the video, or you wait for the video to finish it.
Next, you do some research to figure out the design requirements and your limitations. So in this case, you discuss things like ingredients you have at hand, money you've got to spend, how much time you have before people start showing up, how many people you have to feed, and if any of those people have dietary restrictions. Once you've got a pretty solid list of criteria and constraints, you can start brainstorming ideas for solutions. Maybe you look online at nearby food options. Then, maybe you go to the fridge and you start figuring out what you can make. You weigh your options and you determine making something at home will be cheaper and faster than ordering something online. And you decide everyone likes PB&J, but you don't have gluten-free bread. But you do have corn tortillas.
I guess I'll try PB&J on corn tortillas.
And you make a prototype. You test it out and take a bite. It's gross. But you want to make sure it's not just you, so you get others to test it out, like your roommates or family. Everyone agrees, it's gross. You ask questions and determine what's gross about it. In this case, your testers like the tortillas, but not so much the PB&J. So you go back to the kitchen and reassess. This is what engineers call iterating, making changes based on test and user feedback. You realize,
I've got ingredients for tacos?
Dope.
so you start making some veggie tacos. You try one and think,
This is kinda dry.
you have other people try it to get their feedback. Most people agree. It's kinda dry. So you go back to your kitchen and start iterating again. You find that you've got the ingredients to make guacamole. You make the guac and you add it to the tacos. You test it out and you're like,
This is tasting pretty good.
but some of the other testers think it could use some spice. So you evaluate their feedback, you look in your kitchen, and you realize you don't have anything spicy. That's when you call your friend Sam who's coming over. And you're like,
Hey Sam, can you bring over some hot sauce? I'm making tacos.
and Sam's like, sure. Also, I love tacos. It's now 7:30 and your friends start showing up. You tell your friends,
I made tacos if you're hungry. You can add hot sauce if you want.
And then you and your friends eat the tacos. They're like,
These are pretty good. I'm gonna Instagram that.
You should share the recipe online.
so you do. You've solved your hunger problem and engineered a taco party.
Alright, so again, kind of an interesting way. See if you can grab the lights for us again. Interesting way to introduce, right, our topic, right, the engineering design process. So I want to work a little backwards. So on your worksheet down at the bottom, right, it asks if the engineering design process is iterative. Ashley, what do you think iterative means? Or do you know what it means? What's that? You definitely want to be relevant. In this terms, not quite there, right? Anybody else think they might know what iterate means? It's a language arts term. So if I reiterate something, what am I doing? Restating it, right? So iterate means to, like, is it, in this case, cyclical? Can it happen over and over again? All right, so think about this. So the first step we said was defining the problem, right? What do we do during defining the problem, Derek? Right? Not necessarily the design, but yeah, what the problem is, right? In this case, we had a taco party. We had to come up with a couple of different things. Jacob, do you know what constraints are? Has anybody else heard that term before, constraints? Right? We've heard of restraints, right? Someone's holding us back. Constraints are very similar, right? If I'm constraining something, I'm holding it back or I'm putting limitations on it. So your constraints in terms of engineering are, what materials do I have to work with? What's my time frame? Am I working alone or am I working with other people? Does it have to be a certain size, shape, whatever? Those are part of the constraints, is there are things that I'm limited to, right? So when I'm defining the problem, I have to list the constraints. I also have to list something else, right? And it's what's involved. In this case, we call it criteria. What is it that I have to do? Right? I can't, if I'm given a project, can I just do what I want to do? Or do I have to follow guidelines? Follow guidelines, right? So in this case, my follow criteria, because I have certain criteria I have to meet. Okay, so when we're talking about defining the problem, those are the two things we're really looking at. What are my limitations or constraints? And what is it that I have to do, or what is the criteria? So anytime I give you a project, I'll give you what's called a debrief, and it'll have that. It'll have the objective, it'll have your limitations or constraints. All right, so you'll be able to list those things off based off of what I provide for you for each project. Okay? Let's hear from someone over here. Cohen, what do I have to do after I define the problem? Research. Okay, so if I tell you that, right, my problem is I've got an app on my phone that won't load, what am I going to research? How to troubleshoot, maybe, right? Oh, that's what were you saying? Okay, that's troubleshooting, right? Why is my app not loading? You stated it a different way, but that's fine. Right? Your research might be different than his because of how you put it in. Right? So if you state it that way, it might not give you something as specific, because it might just be like, here's why it doesn't load, but it might not tell you how to get to it. Right? So how we do our research is very important too, right? We have to be very specific about what it is we're looking at, what we're researching. Right? Moses, what do we do after we research? Brainstorm. Okay? Again, so we're talking about, in terms of engineering, again, this can be used in other applications, but in engineering, Chase, when I'm brainstorming, what am I doing? You're coming up with ideas, right? If I've got something where I need to do drawings, am I doing a technical drawing or am I doing sketches? What do you think? Which one would be more relevant for just coming up with ideas? sketches, right? Because what is a sketch compared to a technical drawing? You know? Something simple, right? It's just an idea, right? So if I, if I'm building a model plane, I might just sketch out some ideas. A technical drawing is gonna be more with my final solution, because now I've got my exact measurements, shapes, whatever it is I am doing for that particular project, right? Whereas sketches is just coming up with basic ideas. So during brainstorming, that's what we're gonna do. So as a group, when we brainstorm, should Chase be the only one coming up with ideas? Right, because again, what should we have? Multiple solutions, right? Multiple ideas. Right? What do we do after we brainstorm? We develop a solution, right? So we take all these sketches and possible solutions, and we start to figure out what would be our best solution. Right? That could be building some little prototypes and testing those to see how they work. Right? Because after we develop our solution, then we start to get into building. Right? Again, this is a process we're going to follow throughout this semester with all the projects we do. I'm going to present you with a problem. You're going to have to do some research. You're going to have to come up with ideas. You're going to finalize what idea you want to do. You're going to have to start to build that idea. Right? And then we're going to test it. Jamil, what are we doing by testing? We know what? Okay, so with the prototype good. So what are we figuring out when we test? Let me put it that way. Okay, so when we say iterate the thing, so if I get to this point, do I keep going? What could possibly happen? It could mess up, and what's that gonna do? Now that presents me with new problems. Right, so when they say is the process iterative, that's what they mean. Like there might reach points in the process where I basically have to start over because now I've found new problems. Like the material I have to work with can't sustain this design, so I have to come up with a new design. Right, so that's why we build and test. And that's what the testing does for us. It shows us how good our solutions are, what the problems are, what worked well. Right? And that's when we start to redesign and improve. So Sid, when we redesign and improve, what are we doing? I mean, it's pretty common sense, right? But in your words, what's that? We're kind of redoing it, right? But are we keeping it the same? If we're redesigning and improving? We're making changes based off of what my result. So our PB&J on corn tortilla wasn't a good thing. I could have told you that without tasting it, right? So, right, he made improvements. He changed it up, right? So when we test and we start to redesign, we're going to take what our results are, we're going to use those and come up with better solutions, right? Or we might test it and find out, hey, this is perfect. This worked exactly like I wanted to. Now I can move on to what we call communicating. Mike, what do you think communicate is? Okay, about what the results were, right? Who else might I talk to, right, after the result, like other than just the people I worked with, Lisa? So if, let's say I'm given a problem to solve by a company. Did I talk to that company and tell them how the results worked out? Yeah. That way I can tell them, hey, here's my design for the problem you gave me. It worked great. Or here's my design, here's what some of the problems were. Here's what we're gonna do to fix it, right? So when we go to communicate, we're talking to pretty much everybody involved with the process, not just the builders, but the people we're doing the design for, possibly even consumers, right? If I'm creating something that's gonna be sold on the market, right? I might wanna talk to the consumers and let them know different things as well, right? So I can get feedback from them, right? So, based off of all this, Ahmed, what is the design process? It's that first question on your sheet. What do you think, in your own words, what is it? steps to what? To build something or create something, come up with a solution. Okay. So here's what I want you to do. For those of you that are following along, that got great notes already, appreciate that. For those that haven't, go ahead and take some time on your own. You can either try to go from memory of what we just talked about, or you can use your computer to look this up. So what you're gonna find, if I do research on the engineering design process, you're gonna find all sorts of different lists. Because there are people out there that call different steps different things. Like some people call to define the problem the ask step. Right? I'm asking questions to find out what it is I gotta do. Alright? So what I want you to know for the purposes of this class, the sheet that you have in front of you, these are gonna be the names of the different steps that we will use. Okay? So again, you might see it called something different on a different website that you look at. Just understand that what the process of that step is the same for us. We just call it these things: defining the problem, research, brainstorming, right? These different things, okay? So y'all go ahead and take some time individually. Go ahead and finish taking notes on this. Again, this is what we call a note taker. This is for your purposes. We will have a quiz after we finish our first project over EDP. It's 11 questions. It'll be on pair assessment whenever we get to that. All right, but again, all those questions will cover what we've talked about today and what you'll kind of learn through the first process of our first project. Okay? Tomorrow we'll get into a little bit more of how to evaluate the different steps. We'll introduce you guys to an article of someone who worked out through the steps of the design process to create something, and we'll see who can identify the different steps that individual used. So again, y'all take some time, go ahead and finish filling out your study. Working through a process, what do you think? So like, if I'm doing a project, like, hey, I've done this in keep going right now. Lazy. If I have to write a paper,
Bro, you know what close to the team, he probably is aging them do that. He was like, after their hit the camera, he was like, no. AJ got the ball, and he was like, please, AJ.
But you know, the quick game, nobody was getting was big. Like, the first one? Like, no, the first one, that was, it was a lot, but the second one, like, it was quick, and he could have been able to mix.
Keelan was about to play, he said,
He said, they could have been a lot more, everybody could have been.
you could have been like, bah! I would have jumped up and down.
And then look, they say, AJ, this is tough shot. He did this to us. Like, bro, if we was us there, oh my God.
Look, we in the back of everything, like,
in the projects we're doing here, unfortunately, we won't have a ton of time.
look at me. We on slam, we on slam, we on ballers, like, we on Sports Center up next. We on shot my God. Everywhere.
Who was that girl? Who was that girl with the hat? I'm trying to see who that is. She recorded us, but we were all like this. We was like this. I'm trying to see who that is. I said, shout out Knox Square. No glaze what I said. You know how when they do mixtapes, they record it, they put the sound out, they say something.
There's a video,
Shout out
called
this person.
Taco Party.
What is it?
That's on,
He gonna be so bad, bro.
right, I could about some Taco Party. Actually, done
Yeah,
Taco
that's
Party.
on it.
Bro, I was just sitting there.
It's gonna come back. Watch me.
With a problem.
I was like, all I did
case video, one dude on case video said he seen us in the shot by Kyrie. Like it's so clear that he remembered us. Like he was like, I seen him. Like,
I said, wait, AJ, wait, don't say it.
We probably made it the wrong reason, but we made it. We really made it. We don't slam all this life. Sports Center.
I hate you for playing.
Look, bro, seen y'all get shots by Kyrie. He got 3K. Dudes up here commenting on us so we glazing. We famous, bro. We famous. We ain't folks mixing. We famous. We made it. We made it.
We in a 5-star mix.
Yep. Yeah, this is a 3-year.
Like we in a TikTok mix.
That's why I have.
Bro, I ain't gonna lie. We need to get that video, bro. We made the game on the shot. We was there live, but we gotta get it.
Somebody got it.
Somebody, I swear to God, it's that girl, you know that girl, she recorded. I think she really made it. He made it. He came over and then he just started doing this. I said, oh. That's why I started. What's the NBA dude? He recorded us too. He recorded us crazy.
Bro, I think it's shot by Kyrie. Now that wasn't shot. I didn't shot by Kyrie. I seen him. He was standing next to the girl.
Somebody was at the top.
Girl, she was laughing at us. She kept doing it. Like, shot by
Who's that dude?
Who that dude? People that ran up and down the bench.
Who's that camera?
I don't know, bro.
What I tell you? What he was doing? He said, what did I tell you?
He got his number.
He said, what did I tell you?
I should have been like, who you standing next to? Who them camera?
A car out of the recycle.
We actually famous, bro.
He said, what did I tell you? I told you what he was gonna do.
Connect the balloons.
He did say that.
I ain't gonna lie, he did tell us.
We on Slam, Ballers, Life, Sports Center. What's next? What's next? What's next? LeBron James.
ESPN ain't host us next. ESPN ain't touch us.
Sports Center up next, shit. It's on the Instagram, bro.
Where is it?
And you'll have to basically build a box that will protect the glass.
We really on all them channels.
But the house is coming level 2.
And you can see us visibly blazing.
Hey,
They got 1 million followers.
Imagine we get tagged up like that. If we really didn't know, like y'all got, we would get tagged.
You should have ran on the court. You should have got kicked
You
out.
should have been like this. You should have been like, oh my. I said, what? And we should have got a mix that we should have said, you that nigga, you ready?
Oh, we should have made a chance for that. You. Alright, something like that.
We should have said, you can take
I
off
said,
on.
bro, before he made it, I should have said, boom. They get all the fun stuff. Because you know they make them edit it. It's interesting.
Yeah, you wanna watch the video, it's on CPO5.
Officer told me don't run on the court. I should have said. I gotta get on this bitch. But it was still time left. Now, AJ hit the game winner. When he went back down.
Bro, I told y'all we should stay longer. I knew he was coming back out. They all came through that front door. They came through that front door.
You seen the dude that had the pink spider hoodie on?
Mikey got a picture. Yeah, Mikey got a picture. When he came back out the front door, we could have got a picture, bro. Like, you know when we exited to walk through the door, they walk out.
He came right back out.
Process to help you solve the problem. How does it help you solve the problem?
Like, say if you put something on the board and you just look at it. Or like, you say, look, you say, again, identify the 3D shape. I just go to the Google Classroom, look at the stuff I stuff.
So that's how it helps you solve the problem, by kind of walking through those steps. Okay.
What would you say?
That's, I mean, that's what the design process is, yeah, a set of steps that helps you get to the best possible solution of whatever it is you're trying to solve, so yeah, I can get on board with that. So now the different steps, and what do I do, remember the 2 things I could come up with when defining the problem?
As soon as I get it tattooed.
Are you in here for that, or is that when you stepped out of the bathroom?
We really
technically, yes, right, but I'm keeping you from doing something, right, I'm putting limitations.
Oh, like.
Right, so like if you're trying to jump and I'm holding you on your shoulders, right, I'm limiting you from doing something, right? So constraints, so in terms of engineering, I have constraints, like, I have to work with certain customers, or I have a certain time frame. Right, so those are what we call constraints, or limitations on what we can do. Right, the other thing we have a problem is the criteria. Criteria. What I have to do, right? So like if I tell you you have to build a car out of recyclable parts, can you build a plane? No. Exactly what it is you're supposed to be doing. Right, so that's the first thing I gotta do, is I gotta figure out what my constraints are and what it is that I actually have to do. Figure out what the problem is. How do I figure out what the problem is? So what was I just talking to him about? Did you hear? What are the two C's that we have to think about? Remember that part of the conversation? If I told you I was holding you back. Constraints. Yep. So the constraints are, so I've got a list what the constraints are. What are my limitations? What's the other part? Other C. Come on, Brandon, type. What was the other C? So we just talked about constraints. Criteria. What is the criteria? What does that mean? So like if I tell you you have to build a car, can you go build a plane? No, right? Because I'm giving you the criteria. Here's what you have to do. You have to build a car. So the criteria is what it is you're trying to do. Alright, so that's where the problem is solved, is figuring out what my limitations are and figuring out exactly what it is I have to do. Right? So when we say figure out the problem, right? So we would say figure out the problem by listing the constraints and criteria. So the second one, where you're actually listing what's in each step where it says to find the problem. Well, the first step in the problem, yeah. You can keep that there, right? But find out what the problem is by listing those two things. Hey guys, let's put the water bottle away, since we can't see we keep it on the ground. Let's say, where you can go with it. Thank you. So that one will be, I think design requirements and limitations will be more with the first one. Alright, so if you wanna move that up with the first one, just give me a little more of a definition. Now, when I do the research, what do I do? So let's say I Google how to make a balsa wood airplane. What do you think it's gonna give me? Is it gonna give me just one video of somebody that made that? And what can I do with those videos? Right, I can see what worked, what didn't work, right? So what is the reason I do research is to see if this is already out there, right? Because if it's a problem that somebody's already solved, now I can see what they did well or what didn't work, right? And so now I can help solve my problem a little easier. That's why we always want to do research. If you're just going in blind, right? You know what that means, going in blind? Not knowing what yet, right? It's gonna be a little harder to solve, right? So that's where the research comes in, and that's how we use the research. Finding different ideas and see how they, what worked well, what didn't work well. Those ideas. Yep. Brainstorming. What was one of the things I said with brainstorming? Like, what kind of drawings do we do with brainstorming? Not quite the word I'm looking for, right? Because we talked about technical drawings, but what is a technical drawing? Which part of the process do you think that would want to go to? Is a technical drawing have like final sizes and shapes? So that would probably go with developing the solution, right? Oh no. Not might go with the redesign, because I might take the technical drawing and tweak it. Right, the technical drawing is gonna go more with development solutions, once I come up with my final solution, now I need to know what my actual size is. Right, so we call in engineering, we call those sketches. Right, so like if I say draw a plane, you just do it with a plane, it's a sketch, right? So you're giving me, and so brainstorming is where we start to come up with different ideas and we sketch out those ideas. Right, and come up with just some quick ideas or quick images of what it can look like.
This is simple, bro.
The solution, make it happen, right? So how do we make it happen?
Easy, how is it complicated?
What do we do with those ideas? And we come up with a final solution, or what we call the best possible solution, right? So when we're developing a solution, because we want to have multiple ideas, that way our solution that we come up with doesn't work, now we've got other ones to look at. Right? And when we say develop a solution, what we're doing is we're coming up with our best possible solution. The rest of it is good communicate. You remember what communicate was? Right, so what do you think communicate is? What are you doing when you communicate with somebody? What are we doing? We're communicating, we're talking, right? So when it comes to the process, when you're communicating, what you're doing is you're talking about those results. Right? Did it go well? Did it go bad? Right, you can talk about what improvements might need to be made or what improvements you did make, right? So you're communicating to the people you work with, to the people you're trying to sell to, the people you meet with, whatever the problem is that you're given, right? Like in a company and say, hey, Cohen, make a design for this, right? You're gonna come back to me, you're gonna tell me the results of your design. Communicate with me how it is, right? What you think's gonna work well, what won't work well. So when it comes to communicating, that's what comes. Tell me about the results. Okay? Makes sense? How's it going, Eric? Some good stuff? I'm starting to work as engineers. So engineering design process goes, you talk about the engineers who work with who else about this? Who else? Like, if I own a company, I come to you with a problem and I say, hey, come up with a solution for me, right? Now you're working with me, the company owner, right? Who else might you work with? Management, yeah, part of the company owner, yeah. Could be a CEO or it could just be a manager or whatever, part of the company.
The only thing I don't know.
What about in design that is in terms of building? Who else might I work with?
Look at me, I have my hands up. I have my hands up. Look, go back, I have my hands up.
I'll do a strong picture.
Everywhere, bro.
Most of the things are on there.
Blazing got us
Where travel.
Blazing get you.
Let's be architects, a lot of times we can charge.
This man could go to
Mechanics.
he wants to leave.
What is the best mix you wait there waiting like they're actually
You ever worked on a project?
the best mix is
Design that engineers will come up with.
Best mix drop next weekend.
Is that engineer?
I swear the best mix drop. And I'm in it, I swear I'm gonna cry.
Let's put this here, and you don't think about, oh, this goes back, how do I get that? And so I've changed alternators, starters, you know, transmissions, the parts that, and then you put that stuff myself. And there are times where.
So Justin's nice.
Like, this is
Justin's just that guy.
So, I wish they worked more together.
gonna give it for you get a zero. You're gonna give it for you get a zero. You're gonna give it for you get a zero. We are out here. He tried to slam me, then it didn't work, then I slammed my shit.
Hey, good job today, guys. See y'all tomorrow. starting a new shape or a new extrusion, I always have to click on sketch. I'll start something different. And then I'll select where I'm sketching, and that's when it'll give me my different options. So if you want to try playing with it at home, they do have some YouTube tutorials on Onshape. So, but yeah, I mean, for right now, we're kind of moving on from that, but we will come back to it for other things. So, you're welcome.